It's been traveling for nearly 12 years and has already logged more than 4 billion miles. In its lifetime, it's been to places humans had once only dreamed about. And on August 24th, 1989, at 9 p.m. Pacific Daylight Time, Voyager 2 will make history again. It will become the first spacecraft to fly by Neptune, a planet that orbits the Sun near the edge of our solar system. Launched in 1977, Voyager 1 and 2 have taken us to Jupiter and Saturn. When Voyager 1 flew past the large moon Titan and behind Saturn's rings, its flight path was bent northward, and the spacecraft was sent out of the ecliptic plane and on toward interstellar space. Voyager 2 is on a flight path that takes advantage of a rare geometric positioning of the outer planets. Now, this allows Voyager 2 to use the gravity of the planets it's encountered to boost it from one to another without onboard propulsion. Neptune is invisible to the naked eye. Even our biggest telescopes can see only broad features of the planet. Early pictures sent back from Voyager already show cloud features and a dark band of clouds encircling the southern pole. Neptune's diameter is about 4 times the size of Earth. Its blue-green color comes from atmospheric methane, which absorbs red light. In orbit around Neptune are ring arcs and one of the larger and most interesting moons in the solar system, Triton. At Voyager 2's closest approach, it will pass just 3,000 miles from Neptune's cloud tops. That's closer than Voyager 2 has come to any other planet. A few days before the spacecraft arrives at Neptune, engineers will fine-tune Voyager's flight path over Neptune's north pole. Voyager will be able to detect any Neptunian magnetic field and is likely to pass through the region where the northern lights form. Despite Neptune's greater distance from the Sun, its temperature is the same as that of Uranus. For it to be so warm and yet so far away, Neptune must generate some internal heat of its own. Another of Neptune's mysteries is its moon, Triton. With a presumed atmosphere of methane and possibly nitrogen, Triton is expected to be one of the most fascinating objects encountered in Voyager 2's entire journey. Because Neptune is so far away, radio data from Voyager traveling at the speed of light will take 4 hours and 6 minutes to reach Earth. The signals are received through the Deep Space Network, a global spacecraft tracking and communication system operated by the Jet Propulsion Laboratory for NASA. To provide continuous two-way contact with the spacecraft, DSN antenna stations are strategically located in California's Mojave Desert, near Madrid, Spain, and near Canberra, Australia. The farther away Voyager goes, the more difficult it is to pick up its weak signal. To make up for this, the DSN antennas have been enlarged and are now able to collect more and higher quality data from the spacecraft. The Parkes Radio Observatory in Australia and the National Radio Astronomy Observatory's very large array in New Mexico will join the DSN antennas to provide for additional receiving power. The Usuda tracking station in Japan will help conduct radio science experiments. With the encounter of Neptune, Voyager 2 will complete its grand tour of the 4 giant outer planets and head for its next adventure. The spacecraft is expected to continue to send back valuable data well into the 21st century as Voyager 2 reaches for the edge of our solar system and enters interstellar space. Once there, Voyager will again stretch our imagination as it discovers for us things we haven't even anticipated.